Okay, right. In this lecture, we'll talk about graphs of modulus function and some of the transformations. So first graph is y equals modulus of fx. Modulus of fx. We are already aware of fx, and then we need to draw graph of modulus of it. Now expansion of it is f of x. If fx is positive, so this function is positive, then modulus of fx equals fx. If function inside this modulus is negative, then we need to multiply it by minus sign to make y positive. So suppose this is my f of x. Alpha and beta are roots, and between roots the graph is negative, and outside roots graph is positive. So our principle was, if fx is positive, then we need to retain it, otherwise multiply it by minus sign, which means if graph is above x-axis, then we retain this part, and the part below x-axis we multiply it by minus, which means we revert it by take reflection of it by x-axis. Suppose log x. Okay, log x. Log x is positive from 1 to infinite, and this part is negative. So we retain this particular part and it remains log x, and then we take reflection of this particular part about x-axis. This is the situation, and then equation of this part is y equals log of x, and equation of this part is log of x with minus sign. Okay, suppose sine inverse x. This is my sine inverse from -1 to 1. This part from 0 to 1 is positive. We retain this particular part, f of x equals sine inverse x, and this part is negative. Then we multiplied this particular part by minus, which means take reflection of it about x-axis, and then equation of this particular part is y equals minus of sine inverse x. I hope this is not difficult. 2 examples will suffice. Second is y equals f of modulus x. In this particular part, first we draw fx and then we take modulus of it, but in this particular part, first transformation is x is being replaced by modulus x. Now this expansion is f of x, this equals fx when this x is positive, and f of minus x if x is negative. Suppose this is my graph of fx. Okay, this is y equals fx. Minus alpha to beta, this part is on the right hand side and this is on the left hand side. Now this graph f of modulus x has a beauty. Now if you replace x with minus x, y remains same, which means this graph has to be symmetric about y axis. Now what we do, we simply draw this particular part, which means we erase this particular part and we retain this part on the right hand side of x-axis. And because the graph needs to be symmetric about y-axis, then we take a reflection of it about y-axis. This is the situation. From 0 to beta, f of x, and then this particular side from 0 to minus beta, this particular part is f of minus x, right? So simply what we do, we don't need to do everything, just we retain the graph on the positive side of x-axis and then make it symmetrical about y-axis, because if you replace x with minus x, graph remains same. Suppose this is my exponential function, right? And what we do, we erase this particular part and then make the remaining part symmetrical about y-axis. This is e raised power x, and now e raised power minus x. Suppose log x, right? Entire graph is on the right hand side of axis, then make it symmetrical about y-axis. So this is log of x, which means this is log of minus x. This graph has a domain from 0 to infinite, but this particular graph has minus infinity to plus infinity except 0. Okay, this is sin x is this is sin x. Okay, then we erase this particular part, retain this side on the right hand side of axis, and then make it symmetrical about y-axis. This is the situation, right? Third is mod y equals f of x, which means this equals f of x when y is positive. If y is negative, then mod y equals minus y, which means y equals minus of fx. Now realize one thing, this graph needs to be symmetrical about x-axis. That's it. So suppose this is my f of x, alpha and beta are roots, between alpha to beta graph is negative. Now mod y is positive, which means this particular part has to be greater than equal 0. So we simply erase this particular part and make the remaining graph symmetrical about x-axis. Suppose this is my log x. We erase this particular part and then make the remaining graph symmetrical about x-axis. This part is log x and this particular part is minus of log x. Mod y equals sin x. This was my sin x. Erase the graph below x-axis and make the remaining graph symmetrical about x-axis. So whenever sin x is positive, okay, when this is positive, make it symmetrical about x-axis. This side doesn't have any graph, it doesn't have any value. So whenever sin x is positive, make it symmetrical about x-axis. Suppose we have this transformation mod y equals mod of fx. So the rule is, first thing is we need to deal transformation of x, then f of x, and then only y. So suppose this is my log x and we need to draw log, mod and mod y, this. So first we draw log x, then we draw log of mod x, which means make it symmetrical about y axis. Then we take log of it, which means negative part will be reflected. This is the situation, and then make the remaining graph symmetrical about x-axis. So this is my graph. Okay, it's a very easy and interesting graph, and there is nothing much, I suppose, to talk about it, and we'll solve rest of the questions as we go along.